This is a PSS4 seal installation video. We will be using a vertical pump as an example. However, split seals can be used on horizontal pumps as well. The first and most important part is to ensure safety. Make sure to follow plant safety rules. Use appropriate PPE, ensure that pump is empty and isolated, and make sure that lockout/tagout is implemented. In some cases, access can be difficult. For that, ensure to have stable working platform before starting the work. Pump alignment must be checked prior to seal installation. We will not be covering this part in this video. For work preparation, ensure that all working surfaces are clean of dirt, grease, and debris. Arrange tools and fasteners according to the mechanical seal drawing. Always have the drawing ready for additional information on parts, quantities, piping orientation, and any special notes. Seal parts preparation. Ensure there is no damage or scratches on the seal face running areas. Verify seal markings against the drawing, and confirm that all gaskets are properly seated. Lubricate the exposed gasket surfaces. Verify that circumferential gaskets are properly cut and extend slightly above the surface on both sides. Verify that the O-rings cut is clean and the joint area is flat. Trim if needed. Refer to the example for details. Verify that the set screws do not protrude, as this could cause contact with the shaft and lead to misalignment. If necessary, correct it by unscrewing the set screws. This should be checked on both seal drives. Next step: rotating parts installation. Position the seal drive halves around the shaft, ensuring the setting device rests flat on the pump housing. Place the second seal drive, ensuring it is oriented so the cap screws are accessible for tightening. Push the seal drive halves firmly against the pump housing, ensuring the setting device makes contact with the housing. Apply pressure to the drive, not directly to the seal face. If the drive does not slide smoothly, loosen it slightly. Fasten the cap screws loosely until the seal drive halves make contact, but do not fully tighten. Verify alignment by performing a fingernail test on both the sealing surface and the outer diameter. If a sharp edge is detected, loosen the cap screws and try again. Apply final torque if proper alignment is achieved. If no torque values are specified on the drawing, use 4.5 Newton meters. Each seal drive has 4 set screws. Secure them on the shaft before applying final torque. Check alignment of the two halves. Repeat the fingernail test, correct and adjust if needed. If proper alignment is achieved, apply final torque. Check torque values on seal drawing. Apply final torque in crosswise to keep both seal drive aligned properly. Remove the setting devices by unscrewing the cap screws. Store the setting devices and screws, as they will be needed for disassembly. With this we complete the rotating part installation. Next step: stationary part installation. While not mandatory for the PSS4, it is recommended for vertical installations to use spacers before placing the stationary parts assembly onto the rotating components. This helps prevent damage to the sealing area during gland adjustment. The spacers can be wooden planks or small plastic sheets, provided they are of equal thickness. Ensure there is no damage or scratches on the seal face running areas. Verify seal markings against the drawing, and confirm that all gaskets are properly seated. Verify that circumferential gaskets are properly cut and extend slightly above the surface on both sides. Lubricate the exposed gasket surfaces. Verify that the O-rings cut is clean and the joint area is flat. Trim if needed. Refer to the example for details. The gland gasket for the standard PSS4 cast gland is typically a flat gasket, not an O-ring as shown. In vertical installations, extra care is needed to prevent the gasket from coming into contact with any surfaces, as this could damage the glue joints. Clean all sealing area, stationary and rotating, before placing the first stationary halve around the shaft. Plan ahead to install the gland halves so the stationary split joints do not align with the rotor split joints. Position the first stationary half around the shaft so that the flush connection is properly oriented and the equipment mounting device is accessible. Bring the two halves at an angle as shown. This will prevent having seal faces damage at the split. Push the two halves together, aligning the installation pins for easier positioning. Secure them with the cap screws. Notice the gap between the two glands. This is a crucial step to have the seal faces separated and free to move before alignment with rotating faces. Remove the wooden spacers and gently lower the assembled glands on the rotating parts. Fully tighten the cap screws, but do not apply the final torque yet. Let's examine why proper alignment of the stationary parts is essential. First, the angled second gland ensures that the seal faces stay separated if they are misaligned, as the gap between the glands directly correlates to a gap between the seal faces. Second, if the two glands are tightened before the stationary faces are properly aligned with the rotating faces, any misalignment will become fixed and cannot be adjusted. If the faces are misaligned and glands are positioned on rotating parts, the misalignment cannot be corrected. This installation sequence is incorrect and can cause misalignment, potentially leading to mechanical seal leakage as shown here. Let us carefully examine the correct procedure for installing the gland to ensure proper alignment of the seal faces and prevent any potential misalignment issues. Here the gap between glands is kept and cap screws not fully in place. When the spacers are removed and the glands are lowered into position, the stationary faces will naturally align and adjust to the rotating faces. This is why maintaining a gap between the glands is crucial. It keeps the stationary faces separated until they are correctly positioned on the rotating faces. When the cap screws are fully tightened, faces split joint will be perfectly aligned. Install the equipment mounting devices, typically using studs with nuts or bolts, and hand tighten them loosely. Do not apply final torque. Tighten the cap screws, applying the torque specified on the seal drawing. If not given on drawing, use 16 Newton meters. Evenly tighten the equipment mounting device in a crosswise pattern to compress the springs uniformly and properly set the seal. When the final torque is applied, the anti-rotation pins should extend by 3 mm. Remove centering devices using flat head screwdriver and store them, as these will be needed for seal disassembly. With this we complete the stationary parts installation. Connect the flush line to the seal gland port. For this vertical pump, Plan 13 is being used. Standard PSS4 seals usually contain one flush connection. For this custom PSS4, a second flush and drain ports are available. In this case, close the unused connection on the other stationary seal half with a metal plug. Depending on the seal design, if a drain connection is available, attach a pipe to direct any leakage to a safe location. With this we complete the seal installation. As a final check, rotate the shaft by hand. The shaft should rotate freely without any resistance. Additionally, we will examine some common installation issues. One common issue during split seal installation is the circumferential O-ring extending too far, which can cause the gasket to pinch or twist, creating a potential leak path. When the two ends do not extend beyond the split joint gasket, they align correctly, creating a proper sealing joint. The same issue can occur with the stationary parts, as both the dynamic gasket and the gland are prone to this problem, as shown here. Properly cutting the gaskets to the correct length is critical for ensuring a reliable seal in both stationary and rotating parts. Achieving precise cuts ensures that the ends align perfectly, forming a secure sealing joint and preventing leakage. One common mistake is the excessive use of grease to the O-rings in seal faces split joint. When the two seal drives or glands are tightened, the grease may be pushed out and end up on the sealing area, potentially causing seal leakage. Grease should be applied as a very thin, barely visible coating.